The lightsaber, a fictional weapon made famous by the Star Wars universe. It's one of the most iconic and beloved symbols in science fiction. A glowing, plasma-like blade capable of cutting through almost anything, deflecting laser blasts, and is the catalyst for some of the most dazzling hand-to-hand duels ever seen. What's not to love? But as visually stunning as lightsabers are, do they defy the laws of physics and thermodynamics? Today, we put the beloved lightsaber to the test to see if this elegant but deadly weapon could one day be real. We are stripping away all of the fiction news that allows a lightsaber to function in the Star Wars universe and only apply the physical laws of the universe as we know them today. If you have additional ideas, let us know in the comment section where we can continue the discussion. 1. The problem of energy. Powering the blade. One of the first things that stands out as the most glaring issues with lightsabers is the sheer amount of energy they require to function. In the Star Wars films, lightsabers are depicted as a metallic handle that emits a glowing blade of energy or plasma that can easily cut through solid objects. To achieve this, a lightsaber would need an energy source compact enough to fit inside the handle, yet powerful enough to sustain a fusion blade capable of melting through metal and other materials. This problem is very similar to the issues that Tony Stark's arc reactor suffers with. The amount of energy needed to create and sustain a lightsaber's blade in an independent handheld device would be astronomical, most likely equivalent to the energy output of a small nuclear fission reactor, or about 10 megawatts per minute. The Force does not exist in our real world, so the only way to achieve a level of energy output to create and maintain a lightsaber is to have a fusion reactor inside the handle. But this would create even more problems. A lightsaber's blade would contain plasma, which leads to more complications regarding plasma containment. The fundamental laws of thermodynamics tell us that energy cannot be created or destroyed, and the amount of energy a lightsaber would need to maintain its blade would make the handle impossibly large and unimaginably hot. 2. The plasma blade and magnetic containment. Lightsabers are described as having a blade of pure plasma, the fourth state of matter, which consists of highly energized ionized particles. In theory, plasma could act as a cutting tool, but there are numerous issues with creating and sustaining a plasma blade in the way depicted in Star Wars. First, plasma cannot simply end in midair like a lightsaber blade. In our real world, plasma disperses quickly unless it is confined within a magnetic or physical container. If the lightsaber were emitting a plasma stream, it would behave more like a continuous flame, dissipating after a short distance, and certainly not forming a solid beam that stops after a few feet. Plasma would naturally expand and scatter unless contained by some form of external force, like a magnetic field. Generating a magnetic field strong enough to shape and sustain a plasma blade would require ungodly amounts of energy and specialized equipment that would have to fit in the handle alongside a fusion reactor. Moreover, it's not even clear that creating a perfectly cylindrical, stable magnetic field in the open air that stops at a set length is even possible. Even if the plasma could somehow be contained in a shape similar to a lightsaber's blade, the temperature would pose another issue. Even if the blade of a lightsaber was only 20 or 30,000 degrees Celsius, to achieve nuclear fusion, temperatures exceeding 100 million degrees Celsius are required. A lightsaber with such temperatures would radiate massive extreme heat, making it impossible for the wielder to hold the weapon, let alone safely use it in combat. The intense heat from the plasma would incinerate the lightsaber user before he could even ignite the blade. 3. Conservation of energy and heat dissipation. One of the key laws of physics that lightsabers break is the conservation of energy. When a lightsaber is used to slice through metal or other materials, it appears to do so effortlessly, leaving behind molten edges or clean cuts. However, this process would require a transfer of heat and energy. The object being cut would need to absorb a significant amount of heat energy to melt or vaporize. But the films depict this process happening almost instantaneously, with no apparent heat dissipation or energy transfer to the surrounding environment. In reality, cutting through dense materials with a plasma blade would create extreme heat, causing objects to catch fire or explode from the sudden influx of thermal energy. The wielder would also be subject to intense radiant heat. There's no mechanism shown in the films for how a lightsaber dissipates the enormous heat generated by its blade, yet the handle never seems to get hot. And there's no evidence of a cooling system. This violates the second law of thermodynamics, which states that heat must flow from a hotter object to a cooler one. In a lightsaber duel, the blades themselves would likely cause massive heat damage to both the environment and the combatants. It's simply unavoidable. 4. Weightless blades and the problem of force. Another major issue with lightsabers is their apparent weightlessness. A sword with a blade made of steel carries weight, giving it momentum when swung and requiring strength to wield. In contrast, lightsaber blades are made of energy or plasma, which would not have the same weight as a solid blade. Yet Jedi and Sith fight as though their lightsabers possess mass, with dramatic swings and parries that suggest the weapons have real weight and momentum. In reality, wielding a lightsaber would be more like handling a flashlight than a sword. The lack of mass in the blade would make it difficult to control in combat. The user would have no feedback when their blade connected with an object, making it challenging to judge force and precision. Additionally, the concept of dueling with lightsabers, where the blades clash and create sparks, defies physics. Plasma streams or energy fields wouldn't interact with each other in the way that solid objects do, meaning the idea of two lightsabers colliding and blocking each other is implausible. 5. Impractical and dangerous. As discussed earlier, a lightsaber blade length of about 3 feet could not happen. Energy doesn't just stop in mid-air without some form of containment, so the plasma or energy beam would theoretically extend infinitely, much like a laser. The blade should either stretch endlessly into space or behave more like a lightsaber version of a flamethrower. But let's assume by some superpower that it can. The problem is that you are in essence holding a star in your hand that is into the millions of degrees Celsius. The average temperature of a campfire is about 350 degrees. It can be uncomfortably hot, and getting to within even 2 feet of it is too hot to withstand. Now imagine a multi-million degree fusion reactor in a lightsaber. The heat would melt everything nearby and incinerate its user. Unless there is another viable form of energy that we do not know about, these temperatures in themselves makes a lightsaber impossible. But again, let's say that there's a fictional energy source called the Force that allows for a 3-foot blade that somehow dissipates all of the heat generated. If you accidentally touched anything or anyone, it would result in serious injuries. If you were in a one-on-one fight with lightsabers, it would be impossible to avoid small interactions with the blade. It is 100% impractical, and you would most likely end up accidentally severing a hand or fingers unintentionally. While lightsabers are visually captivating and thrilling weapons in the Star Wars universe, they remain firmly in the realm of science fiction. The many violations of the laws of physics and thermodynamics make them impossible to create, given the laws that dictate our universe. The challenges range from the immense energy requirements, difficulties of plasma containment, heat dissipation, and the unreal interaction of weightless blades. Despite this, lightsabers continue to inspire imagination and wonder, serving as a reminder of the vast potential of human creativity, even when it defies the rules of the physical world. In the end, lightsabers will remain a beloved fantasy weapon, fascinating to dream about, but impossible to build. We thank you for joining us on our analysis of lightsabers and invite you to join us in our next episode.